Now try to solve these questions within the specified time. Now let us see the solutions. In the first question, it will be much better if you try to solve this question through signal flow graph. Otherwise, it might take you at least 5 times more time if you try to solve it through the rules of block diagram. The block diagram can be easily converted into signal flow graph as shown on the screen. After that, we have to simply put the Mason's-Gain formula for finding the transfer function. You have to be careful in finding the number of independent loops in this signal flow graph. Now let us see the second question. First, we try to find the characteristic equation, and to find that, we have to first find the transfer function. After finding out the characteristic equation, we will get to know that the characteristic equation is an equation of second order. Interestingly, we are provided two poles in the question itself. Now, we can simply put the value of different poles to find the characteristic equation. After that, we have to compare the coefficient of different powers of s, and after that we will get 3 plus k equal to 6 and 2 plus k alpha equal to 14. By solving these two equations, we will get k is equal to 3 and alpha equal to 4. Now let us come to the third question. This question is very simple. You can find the answer by simply first forming the root array and equating the first element of the third row with 0. Now let's see the last question. This question is actually very interesting. It is very obvious in the question itself that you have to form the root array. But for the fifth row, it is upon you which case you want to prefer, because there will be only one element in the fifth row which will come out 0. Now, it is upon you if you try to solve it through the case 1, where the first element is 0 with all the other elements having non-zero values, or the second case in which we are having a row of zeros. But here there is only one element, so you can solve this question by any method. Actually, there is a maximum limit on the number of elements a row can have, which depends upon the power of s. The row corresponding to s raised to the power 1 can have maximum number of elements equal to 1, which in this case will come out to be equal to 0. So here only this is valid that you can solve this question through any of the two cases which we have seen as special cases of Routh-Hurwitz criteria. I will prefer the method which is not very common. Rather than treating it as a row of 0, I will simply consider a single element with value 0 in the fifth row and will replace the 0 with an arbitrary small negative number. Now, we can clearly say that there is a sign change between the third and the fourth row. Since there is one sign change, then definitely there will be one pole which is present in the right half of S-plane. We have already discussed the two possibilities, one of which was if the sign of the coefficient above the 0 is same as that of the element below it, then it indicates that there is a pair of imaginary roots. Therefore, the number of imaginary roots in this case is equal to 2, and the remaining roots are lying on the left half of S-plane. Therefore, the value of L is equal to 2. So, the first option is correct. This question is a good example where we are supposed to take a negative value of epsilon. You should always remember, it is not necessary that every time the value of epsilon has to be taken positive. Here also we have taken the value of epsilon negative. I hope you will keep that in mind.